Hello everyone, my name is Javed Kamar and I am a research scholar in Metallurgical and Materials Engineering Department NIT Warangal, working under the guidance of Dr. Mahesh Kumar Talari, and I am here to do a TIG welding of our material, which is CP titanium. So basically in TIG welding there is a power source table movement arrangement in which we can control the speed of the weld, which is also connected to the control panel where we can set the required speed. And here it is argon gas, which is basically required for welding of any titanium material, because during welding there is a chances of oxidation to be happen, so that must be protected by the argon gas. So that argon gas supplies is divided into two parts. One is went to the power source, and from power source it will go to the electrode and that torch, and the another part is coming and divided into three parts here finally in the table, in which the first part is the trailing gas. It is called trailing gas, which helps in protecting the finished weld, like the welds which is already finished, since the table moved from this point to this point, like this is the starting point and this is the end point. So as it moves, the trailing gas will move along with the torch, and it helps in protecting the welds which has already finished. And this is the backing gas, which helps in protect the base of the material from inside, so that from inside also there will be a less chances of oxidation. So these are the fixtures on which we fix the plate. So now we start our first step, which is to fix the plate on the fixture for a proper weld. This fixture is required to prevent the plate from thermal deflection, and also it is made of copper, so that heat will easily dissipated from the weld zone to the fixture and ultimately to the atmosphere. So for this arrangement we just need to put some nuts through the holes. So before starting the weld or before fixing the plate into the fixture, we first need to ensure that this copper base must touch to the plate here must touch to the plate all over the weld, so that it helps in heat dissipation through the welds, and also it supports the weld zone. Here, as we can see, it is not touching the plate, so what we will do is we will keep some extra plates here at the base, so that it will rise above and it will touch the plate. Let's see how we do. So here we have some thin plates which we are going to keep it on the base of this fixture to increase the height of this copper rod. First we start with some 2-3 pieces, and then we will check whether it is touching or not, and then we place the next. If it is not, then we put some more plates over this. So now I have added one more plate on the base, so that the height will be enough so that it will touch the plate. We'll see after keeping the plate at the bottom, this copper base will touch the plate. Still a little bit gap is still there. So what we do is we will keep one more plate over there so that it will touch, this portion will have to touch the plate. Now we have kept one more plate, and now we will check what is the height. I think this time it should touch. Yes, now it is in complete contact with the plate, as you can see. So our next step is to fix the plate to the fixture. Before it, we will just check whether the electrode movement is on the top of this rod, this copper rod, or not. For this we need to switch on the control panel. So basically this is the control panel from which we can change the speed, and this is for the forward and backward movement of the arm, this arm, weld arm, in which the TIG torch has connected. And this is the another button which is used to switch on the TIG and switch off the TIG. That is nothing but the arc. So we switch on the control panel. Since this USB is already on, so this display has come here. Now we have already set the speed to 150 centimeter per minute. Whatever the speed it will come here, it is in centimeter per minute. It is in millimeter per minute. And now we will see, like when we switch on the movement, the arm will go that side. When we keep it down, this will come back side. Okay, so we need to start from this point. So first we need to move the arm to the start point, and between this movement only we need to check whether the movement of the electrode is on the top of this base or not. So as we can see, it is completely on the top. So the arrangement of this copper base is correct according to for this weld. Yes. Now our next step is to fix the plate. So this plate we are using is about 100 mm in length and 100 mm in width, and one weld, as you can see, is already performed. This is just a trial plate. Before the welding, I just want to ensure that it will form a proper weld, so I am using a trial plate before going for the actual welding. So let's start. So to fix the plate, we just need some plates over both sides. So these plates will help. This helps in a proper fixing of the plate. So now I have fixed the plate from the both side, and also our trial plate at the middle on which we need to weld. And before tightening this fixture, we first need to ensure that it should be at a minimum distance from the plate. These two blocks should be in minimum distance to the plate, to the weld plate, and this is because that this is copper, which will easily extract the heat from the plate, and it will protect the plate from some thermal distortions. So now our all arrangements are completed. So we fix the plate through the nuts. For fixing this one, we just need a Allen key of this size, so that it will be a completely tight. And also we need to like when we are tightening this screw, we need to take care that we do not have to tight fully tight at one end. And what we need to do is this end we just tight it slightly, and we move to the next end. And also here we tight it not completely here also, but a slight one. And then again we move here and we tight it completely this time, so that the plate will be fixed from this side. So now these both screws are completely tight. As you can see, this fixture is completely fixed with the plate. And now we need to tight this side in the same way. We first tight it slightly, not completely, and then we again tight this one. Now this time we tight these nuts completely. So now the fixture is completely fixed. So as you can see, we have kept some plate. That plate is helping this slabs, these rods to be complete horizontal, because the plate is limited up to this length. So after tightening, there is a chances that this block may inclined from both side. So to protect this, like to prevent this block from inclination, we have kept one extra plate from both side. And also, as everything is ready here, so we will move to the next step. So our next step is to give input to the parameters into the power source. For this, we first need to switch on the power source from the main power cable. So as you can see, it is switch on here. So to switch on this power source, we need to rotate this knob to the start and just leave it. Again it will come at the middle. Now you can see this light has closed and these lights has started glowing here. So it will take some seconds to start it completely. Until then, let's just wait. As you can see, now the current is 60 ampere, and our parameter for this material is our parameter is peak current. Okay, so we need to do in DC pulsed welding. So to move this power source to the DC pulse welding, we just need to press this button. It is already in DC, so we can, as we press this one, it will move to the DC pulse welding, and if we press again, it will comes to AC, and we have to do our welding in DC pulse. So DC pulse. So now we can set the parameter of pulse welding. That parameter we need to set by these indicators. Here this light shows the peak current value, which is here is 60. We need to make it 240. So we need to increase the current from 60 by rotating this knob. It will becomes 240. Until then we need to rotate it 235, 40. Okay, so our peak current is 240. Now background current is 50 ampere. Peak time is 0.15, background time is 0.1. So to set the background current, we need to press this arrow button. That will be okay. So that will comes to peak time. Peak time peak time is 0.15 seconds. So here it is already 0.15. No need to change, or we can, if for other welding, if we need to change, we can change by rotating this one. For this it is 0.15 already. Now we press this button. That will show the value of the background current. So this the downward value is nothing but the background current. This value shows the peak current. So background current is 50. Okay, then yes, background time is 50. Now the background time is 0.1 second. So if you again press it, it will comes to this one, and that will shows nothing but the background time, which is already 0.1 seconds. So this is how we need to set the parameters for DC pulse welding. So our parameters is I have given in this power source. Now to start the weld, we need to just put this copper plates over this place, so that when the gas will comes, that backing gas is coming, it won't escape to the atmosphere. It will go behind, or it will go to the back side of the plate. So we keep this copper rod from the both side, because we are supplying the backing gas from both side. So yes, so now whatever the gas will coming from the back, it will directly go to the plate without escaping to the atmosphere. Okay, so after the complete arrangement there, we need to switch on the gas. So now as you can see, this is showing zero pressure here and zero flow rate here, and as we open this knob, you can see there is a rise in pressure, and also the flow rate we can regulate by rotating this knob. So for our welding, we will use somewhere around 21, and also it is in liter per minute. So now we have started the supply of the gas. So before welding, we just need to, now it is ready for welding. So before welding, we need to just ensure that everything is perfect here. So first, gas is on, we have kept the parameter, we have set the speed, and now we will start the weld. So yeah, so we start the movement after the electrode. So before welding, we just need to maintain a minimum arc length of 2 mm for 3 mm plates. So this is a 2 mm thick plates, from which we will keep it, and we will keep the electrode at the top, and after that correct position of 2 mm, we will remove this one, so that the electrode length from the electrode height from the plate will be 2 mm exact. So now we have set the arc length. Now we start the welding. So you can see it creates an arc. So here what happens is the electrode touches the plate. I think this is because of the loose tightening of this electrode, which comes down while we start the welding. So we can remove this plate, and again we will grind the electrode and make it sharp before our next weld. So here you can see at this place at this place the tip, the electrode tip has touched the weld zone, so this is not a proper welding. So now what we need to do is we need to take out the tungsten electrode, and we need to grind this one. So to take the electrode out of this torch, what we need to do is first we need to switch off the power source for safety. So we have switch off the power source. Now what we need to do is we need to lose this one, and we need to take this torch out of this arm. Okay, so now we've taken it out. Now what we have to do is again we need to open it from this end by rotating this one. As you can see, after certain rotation, that electrode becomes loose and it will comes out. See, so now the electrode tip is blunt. You can see this touches the plate during the welding, so it becomes blunt. So now what we need to do is we need to grind it and make it sharp, and for that we need to bring this electrode to our grinding machine. And while grinding the electrode, please make sure that we need to grind it by keeping it vertical, not like this. After the grinding, you can see the tip is now complete sharp, and after complete grinding we will again fix this electrode to the torch. For fixing the electrode to the torch, what we need to do is we need to insert it from here, like the same way we have taken it out, and before fixing it to the torch, we just need to clean the tip from some tissue paper. Here we have this tissue paper in which we'll clean this tip first. And after that we keep it inside the torch the same way we have taken it out. It will smoothly go inside, as you can see, and we just keep some. We need to tight it in such a way that the tip should be outside of this ceramic cup, just a little bit outside, not too much. Too much is also not required, that much is not required. It is just like that. The tip is just outside of this ceramic cup, and after that now it is in sufficient height, so we can now fix it by rotating again this one. Yes. Now the tip is fixed. As you can see, after complete tightening it won't come out, it is completely fixed. again we will keep it here. And we will tight it so that this electrode won't comes down again. Since to maintain the arc length 2 mm, we just inserted a 2 mm thick sheet between the electrode tip and this plate. Since it is still not in contact, so what we need to do is we need to loose it from here so that it will come down. Okay. So now it is in contact. So after the complete contact we will tight it and we will remove this plate. So now the distance between the electrode tip and the plate is exactly 2 mm, and we will start a new weld from here. And before starting again, we need to check the electrode should be on the top of this copper block. So since this is an arc welding, we need a protective glass. So as you can see, the welding has started now. That blinks will indicate nothing but the pulsed current. So after the complete welding, we will stop the weld. So after welding, as you can see, there is a pattern in the weld which shows the pulsed welding, and this is the start point and this is the finish point where we have ended the weld. So this is our trial plate and the weld is nice one. So our next task is to weld this plate in which we have made a groove, and on that groove we will fix the electrode. We fix the electrode and we will do welding on this particular length. So that is the basic thing of how to do a TIG welding. So thank you everyone.